and thank you for watching Pulp&Fuel Learning. This online training course was created by the project Pulp&Fuel. The objective of this training course is to promote the possibilities to integrate biofuel production in a pulp mill. My name is Geert Haarlemmer. I'm a research engineer at LITEN in France. The LITEN Institute is focused on renewable energies and in particular the carbon cycle. My main activities and area of expertise are in process engineering and in particular biomass conversion and biofuels. My current focus is on hydrothermal processes. The European Union has set an ambitious target to include at least 14% renewable energy and 3.5% advanced biofuels by 2030. Our work is part of a call in 2018 that specifically aims to produce road fuels. A word on the consortium Pulp&Fuel. The project aims to develop a valorization pathway for paper mills to produce biofuels. This project is funded by a Horizon 2020 research grant, uniting 10 partners from 4 different European countries. The concept elaborated by the Pulp&Fuel project is to integrate biofuel production in the regular production cycle of the pulp industry. Trees are separated in stem wood and bark. The stem wood is chipped and transformed in the cooking step using chemicals. The cooking chemicals are mainly sodium hydroxide and sodium sulfide. Lignin and hemicellulose are dissolved by the cooking chemicals. Cellulose is insoluble and is separated and sold as pulp after bleaching. Pulp paper is made from pulp. The black liquor is a watery process stream containing spent cooking chemicals, dissolved lignin and other organic compounds. This black liquor stream is typically concentrated and burned in a recovery boiler, supplying heat to the process. Another source of heat to the process is from the bark boiler that incinerates the bark that is rejected at the inlet of the process. We see that a significant amount of carbon is rejected in the 2 boiler furnaces. The process is often limited by a bottleneck on the recovery boiler and is a net producer of heat. It is therefore interesting to convert the black liquor and the bark into synthesis gas instead of CO2. Gasification technologies convert an organic carbon source into a synthesis gas, producing a smaller amount of heat. The synthesis gas can be converted into a transport fuel by means of the Fischer-Tropsch process. The 2 different gasification technologies were required. Bark is gasified in a fixed bed or in a train flow gasifier to produce gas rich in carbon monoxide and hydrogen. Black liquor can be gasified in a supercritical water gasifier, producing mainly hydrogen and methane. The mixture of these gases allows the synthesis of a diesel-like road fuel using Fischer-Tropsch process. The project is divided in various work packages that are led by specialists in their field. The project is coordinated by CA and APSIS-K. Representatives of the pulp industry, Fibre Excellence and the engineering school INP Padua supply the project with knowledge on the industry and data and resources. The gasification work package works on fixed bed gasification at RISE ETC and on train flow gasification at CA LITEN. CA LITEN also works on supercritical water gasification of black liquor. The produced gas streams are cleaned and made up to specification by SYNTEF. SYNTEF also optimized the Fischer-Tropsch process synthesis to our particular situation. The generated experimental data is used to create a detailed process model by EPFL that forms the basis of the process optimization and engineering by the engineering company Softseed. The manufacturer of high-pressure equipment, Top Industry, designs the supercritical water gasification equipment. The concept and the process are evaluated economically and for their social and environmental sustainability by IVL. The main objective of this project is to propose new products to the pulp industry. We have shown how the biorefinery concept of the pulp industry can be extended to produce biofuels without negatively impacting the production of pulp. Gasification yields can be improved for complex resources such as bark and black liquor. The project proposes a demonstration plant and shows that for a large-scale application, production costs can be competitive. This video is an introduction to a series of videos that are listed here. Each video will focus on a particular theme in the project. The overall objective is to transmit the knowledge generated in this project and to inspire the pulp industry to move into biofuel. I thank you for your attention and we all hope you enjoy this series of videos.